let's do our coming into the room together first. So take this time to just not do, be good for you. All right, so you can follow along or you can do as you see fit. I don't have many instructions, except notice the bottom of your feet. Can you notice each toe? That's a little tricky for me anyway. And then just letting that attention widen. Taking in the sounds and the temperature in the room. Noticing if you have an expression on your face. And lastly, just setting an intention for the day. What is it you hope this day holds for you? All right, let's come on back. That was easy. Mine was, I hope it holds motivation, because I'm already ready for a break. It's like, I don't think I'm alone. Sounds like it. Let's do a little warm up, friends. So just chatting, beginning. I don't think anybody new's come in since then. We feel okay about the homework. That is cool. Probably an exam in maybe 2 weeks, something like that. Definitely will give you the full heads up, week notice, so I'm not gonna just pop that out. But I think about 2 weeks from this week sounds good. Probably the Wednesday of that second week. But let's just warm up. So I've got a couple functions. And I would like you to find a couple of things, please. So F composed with F of 0. And then G composed with F of X. And then one more. Let's do F composed with G of X. So let's do that composition in both orders. Simplify as much as possible. Things should be pretty if you simplify it completely. So give that a shot and see what happens there. We'll talk about lines and do some problems and probably work on the homework online. We'll do this warm up all of always through class, just kind of reminding ourselves what's going on, getting ready for the exam just every day. this guy. Who is that? Who's that guy?
That's Andy Reid.
Oh, okay. Okay, that's like a sports guy.
Yeah.
Okay. Pretty bad on that stuff.
It's okay.
It's like a coach for something.
He's a coach for the Kansas City Chiefs.
Sweet. Oh, you're from KC? Nice. I'm from Belleville, Illinois.
Okay.
Like just down I-70 straight
Right,
across
right,
in Illinois
yeah.
on the road from you.
Yeah, you
Yeah.
really are.
Bless you. Thank you. Did I do okay? Yeah, cool. Good, good. Is there any questions about any of that? Anything you want to go through? And if you want to talk in private too, we can absolutely do that. What do you call, so if I have these functions g and f, that when I compose them, I just get back x. Anybody remember, what do you call g and f? What is they're related.
Are they the inverse of each other?
They're inverse functions, yeah, absolutely. So these two right here, f and g, are inverse functions. So if you take a number and you run it through f, so for example, if I take f of 2, that is 1. And if I take g of 1, notice that I get 1/2 plus 3/2, and that gives me 2. So it undoes, it goes in the other direction. Just a little reminder there. Cool, warm up has ended. Let's do a quick review of lines. Oh, and so I've got 2 homeworks open. I've got the homework 1-3, I think, is on lines, and that's open now. Nobody's done with that yet, are they? Yikes, okay, great job. Wow, okay, you're moving fast. And then I opened homework 1-4, and that is on exponents. And this one, I wasn't gonna talk about in class. If you could just see how that goes and watch the videos as you see, it's a very short section. And then we'll talk about whatever you need. But, so just a quick review on lines. And I've probably got a slightly different take on this than you've seen, and I want to point out a few things as well. So a line in the plane, we need 2 pieces of information. 2 pieces of info to construct a line. At the most basic level, I need a point and then another point that the line passes through. So one way to do this is 2 points in the plane, or a point and a slope. So let's first talk about the general equation of a line. So general equation, and then we'll build one a couple of ways. General equation, and some forms that you're going to want to kind of get used to. So anything, I've got a constant times x plus any constant times y equals a constant. So here, a, b, and c are constants, and they're real numbers. Everything in this class will be real numbers, so we never have to worry about that. Sometimes this can be not super informative, So what we do is we use the algebra, so use algebra, to get it into this form, y equals mx plus b. So move the ax to the other side, divide by b, and you get it into this. What, does anybody remember, what's that m represent? That is the slope of the line. And what is the slope of the line? That's a little harder to say, yeah, but yeah.
Kind of like the rate that it like increases or decreases, right?
Yeah, it's the, and that's the way we want to think about it in this class. It's a rate of change. So the slope equals the rate of change in y with respect to, so that WRT, that's something we'll get used to more and more through the semester, with respect to x. And in fact, m can be thought of as the amount that y increases if x increases by 1 unit. If this were some sort of cost function, that would represent a thing called the marginal cost. So marginal things in business are just rates of change. It's the rate of change of some output quantity with respect to 1 unit of change on the input. So, okay, let's just put that here. Marginal change. And what is B? What does this B represent? It's not as helpful, but sometimes it can be helpful. Anybody remember what the term for that B is?
Is it the y-intercept?
Beautiful. Yeah, it's the y-intercept. Good stuff, Lisa. So this is the y-intercept. And do you feel like what is that?
Like where it is on the y-axis?
Yeah, where it touches the y-axis. Yeah, absolutely. So we've got this line. Let's draw a little fake out here. So let's say it looks like this. This is B units right here, and that M represents, you can think of it like this. M is the height I go up if I move over 1 unit. Now I'm saying up, but it could be down too. If M is negative, you're gonna go down. But a good way to think about this for the whole rest of the semester is as a rate of change. It's a little bit of a shift from what you're used to when you're just like thinking slope and stuff like that. Okay, so this is a form that we usually shoot for. We take all our information and we eventually end up with an equation that looks like this, but it's not how we usually get the equation. So let's talk about creating an equation for a line, or review it, since some of you are done with the homework anyway. So how to create an equation for a line. Let's go with the 2 points first off. So 2 points, and we've got, we'll say x0, y0, and x1, y1. Let me draw out what I mean, because that's just letters. So let's say I've got x sub 0, y sub 0, and then x sub 1, y sub 1. And I want the line that goes through there. When I say I want the line that goes through there, what I mean is I want to be able to figure out what is the y that corresponds to any x. I want a formula that I can give to someone that helps them do this computation. Except for beyond these 2 points. So, step 1 is find the slope. Find M, the slope. And the slope is just going to be here, the change in y over the change in x. So M equals change in y over change in x. And that means if I have 2 points, I can just take the difference in the y coordinates. So I'm going to take y1 minus y0 over x1 minus x0. So this distance right here, that's x1, that's x0, and this right here is y0, and this is y1 up here. This is getting a little sloppy. But I'm just taking that change over that change. Find my slope. That is constant all the way through. The rate of change in a line never moves away from this value. It is constantly this value. So step one is that. Step two is use point slope form. Point slope form, I haven't written it up yet, is as follows. Y minus the y coordinate of some point we know equals m times x minus the x coordinate of some point we know. So where m equals slope, O is in this class, and x naught, y naught equals any point on the line. So I could use either of those points that I'm given in this process, and it works out great no matter what. So you literally just plug those in, you're good. Once you plug those in, you've got the equation. You might want to rewrite it now. To write in y equals mx plus b form. So using algebra, then we get back to that form. That's about it. If I knew a point and the slope, I would just go right to this form right here. So friends, let's do some problems. Just practice on this. And since you've done the homework, many of you, this should be pretty good. Could we take a look, please? We're gonna go to page 40 in our book. And I would like to spend a few minutes on number 1, please. So if you could just work that through to the best of your ability. We're looking for an equation for the population T years after 2003. Hello. Good morning. When you get settled in, we're working on page 30, first problem. Glad you're here. Is the traffic bad?
Yeah, and then
Parking?
sometimes my dad needs help with like Excel things or something.
Really?
Yeah, so I have to
Do
figure it out.
spreadsheet things?
Yeah, before
Really?
I go.
What does your dad do?
He like has his own remodeling company.
Cool. He needs you for the tech support.
Yeah, or sometimes he just doesn't know how to spell something, and he's like, "Can you check my spelling?" And I'm like, "Yeah."
That's cool. You're very kind. That's good. I'm sure he appreciates you a lot. Let's kind of gather together on this. What are my steps here? So, what is a point here? We need at least one point. What is a point on this line? Yeah, Jen.
45,000.
Okay, cool. So you are, and we can do this a couple of ways. So Jack is working from relatively with respect to 2003. That's cool. Yeah. So this first variable here is going to represent years after 2003, and I'll show you another way to do this too afterwards, kind of how I thought about it. But is this cool with everybody? Did anyone use 2003 here? Wow, that's amazing. Cool. You're all on the same page. I'm on a very different page. Cool. We'll do it my way too. I love this. So that's a point. I don't have a second point, but I do have this piece of information. What is that in terms of a line?
The slope.
That is the slope. That is a rate of change right there. This is the change in the population over the change in time. Getting used to writing that notation there with that delta means change. So this capital delta, that's change. I've already used it probably before and I didn't say that very clearly. So I've got my slope and it is 1700, and at this point we can just rock it out. So notice here our variables are t and p. So using this form is where I'm going. I've already got that and the point. So we're gonna get population minus, actually I'll write it out here, minus p naught equals m times t minus t naught. And so this p naught, p for us is, yep, t years after 2003. So at 2003, the population difference, I guess you said, was 0. Is that right, Jack? Did you use 0 here, or?
I did the 45,000 there.
Okay, so let's see here. So p minus 45,000 equals. Oh, that's right, because it's our input. No, yeah, all good, all good. And then this is just going to be 1700, and then we have t minus 0. Yeah, sorry. Yep, all good. So p equals 1700t plus 45,000. And then we have our equation that we can use to do all sorts of predictions with. Let me just show you my route really quick, and I think we'll get to the same place, but let's just follow it through. So I was thinking when I worked this through that t equaled the year, not the difference in years, not how far we've come from 2003. So my point looked like this, and in year 2003 we had 45,000. Slope was the same. So when I work that through, we're going to get p minus the initial population equals the slope times t minus my starting year. And so here we're actually going to get a slightly different equation. We just have to keep in mind what t represents. So here, t equals the year, not the number of years that we've gone forward. So here, p equals 1700t, and then gosh, I don't know what that number is, 45,000. Actually, could someone just do that for us really quick, please? 1700 times 2003. What is that quantity right there? I don't even know if it's positive or negative. I guess I hope it's positive.
No, it's way negative.
It's way negative. What'd you get?
Let me see.
Oh, I got a good conversation we can have really quick right after this.
Negative 3,360,100.
100 just like that?
Yeah.
Wow, cool. So let's check out, these are two functions that represent the same thing, but the domains are really different. So here, the domain of this function, this expression right here, is from 0 on up to infinity. The difference in the years. But for my function, the domain was from 2003. So that's the minimum value I would put in here. That's why this looks kind of crazy. If I put 2003 in here, then I'll get 45,000 out. Okay, cool. There's more going on there than I thought. Is this all good? Does this feel, yeah? Katya, is this kind of settling in okay? All right, cool. All right, let's do another one, friends. Let's try on the same page, number 11, please. Just to practice the whole building a line thing, and let's put our final answer into y equals mx plus b form. So we'll get that up here, so check that everything else. Are you feeling okay on the homework and everything? Okay. Yeah. Okay, cool. Oh, and then the one other thing is we'll probably have our first exam in like about 2 weeks, something like that. That turned out real pretty. Double check. Looking good. Cool. Feeling okay about this? Yeah, cool. Let's do one more problem. And I think the good one to do off that section would be number 33 on page 42. So multi-part problem there. Let's spend some time and then check back in together. Yeah, better take it easy there. 2.1 billion is. I don't think I have enough zeros there, do I? That's not right. I'm not used to writing billions. There we go. Probably should just say the units are in billions and like make our lives a little bit better. But you know, what the hell? Let's have fun with these have fun with these zeros here. That's a little ridiculous. But I think that's about right. Is that looking okay? We basically subtract off for each year that passes by, we subtract off this much. And so this is a silly way to write it. RT equals, let's see here, so there's 9 zeros there, so it's 16 times 10 to the 9th equals negative 2.1 times 10 to the 9th t, oh, well, plus, let's have that there. There we go. So I just added this to both sides and wrote it in scientific notation. And this just keeps track of the number of zeros, or just the powers of 10 you're gonna multiply this by. I mean, if you don't remember this exactly, this means move the decimal point 9 places to the right, and you'll be good to go. So, okay, cool on this? Yes?
On a test, would you want us to put scientific notation like that, or would you?
Oh,
rather
I'd
just
be
write-
happy if I saw it, or if I didn't, I wouldn't
just
lose like
we
any
just did
sleep.
The 2.1.
Yeah.
Okay.
Yeah, just more compact.
Okay.
Honestly, the smartest thing that I should have done here was just say amount in reserve in billions. And as soon as I do that, then life just becomes so much simpler. If we do that, then we've got R equals 16 minus 2.1t, and boy, isn't that smarter. Yeah, that would have been, that's the move to make. So setting our units can make life better. How do we do part B? Has anybody got that yet?
Just put plug in 5 for t.
Perfect. So for part B, so this is part A. And actually, let's make this part A. I like that better. So we're gonna do the in billions. Just so much less hassle and less error prone. So for part B, we're going to let t equal 5, the number of years after 2010. So the amount in the reserve is 16 minus 2.1 times 5, and that is 16 minus 10.5, is that right? Yeah, okay, cool, thank you. And then 15.5, right?
5.5 is.
5.5, thank you
Yep.
for checking on me. I'm not well. And then that's billions of gallons. Billions of cubic feet. Cool. Yeah, thanks, I get the thumbs out, I feel good. Feels good to get a thumbs up. Okay, cool, how do we do part C? So if the depletion rate doesn't change, which is highly unlikely, but let's pretend, when will the reserve be depleted? How do we discern that? Jack, yeah.
We would set RFT as 0.
Yep, exactly. So figure out the time when RFT is equal to 0. So when we go to do that, we're gonna get 16 minus 2.1 t equals 0. 16 equals 2.1 t. So I probably do need a calculator friend here. T is 16 over 2.1. What's that?
7.619.
Oh, nice. What was that again?
7.619.
Thank you. And that's in years. So, sometime in July or something like that of the 7th year. If we're starting in January. Cool. Does this feel good? Who has not finished the exponent homework? Is that everyone? Or have you all finished the exponent homework?
Is that 1.4?
That's 1.4, yeah.
I don't think 1.4 is open, at least on mine.
Oh.
Yeah, it hasn't been
Yeah, I can't
posted
see
yet.
It hasn't been opened? Well, that's crazy. Cause I kind of, you guys are all moving so much faster. I was gonna give the rest of this time to work on the line homework. Does anybody still need to work on the line homework?
1.4 is open now for me, Adam.
Oh, cool.
It wasn't like
Yeah.
20 minutes ago.
I think I had it open at 10,
Okay, yeah.
so we're good.
Yeah.
Awesome, and no one started on that yet then, cause you couldn't. Awesome. Now we have to like slow you all down so that we have stuff to do. Cool, let's just finish our homework the rest of the hour and maybe walk out of here with nothing to do at home, except help Dad with whatever. Dad will appreciate it. And let me know, I'm here to consult with you. So if you are like, I don't remember this, or what's happening, let me know. start getting a little more interesting. Wednesday. Okay, we good? You keep, yeah, rocking. And if you get done, if you can say you can chill here, or you can chill somewhere else. I'm not gonna hold you. Hi.
Hi.
Cool, excellent, thank you. I need help. I need stuff to do, Caroline. Yeah, so how to move forward with this? Let me come over. Cool. So, let's see, what do we need to do? Oh, so kind of simplified is essentially. Oh, and they want us to rewrite it like that. Got it. So let's maybe go through a little bit at a time. What would be your first thought here on what to do?
Hopefully I would, do that one.
Yeah, let's do that. And what do we get? I like that. That's a great first step.
Okay, so do I multiply with the C2 or no?
So what do you mean?
Like, no, okay. No, I think I'm overthinking it.
Maybe. We'll find out. We'll find out. So yeah, what's the new exponent on C? Yeah, beautiful. You're doing it perfectly.
Okay, and
Yeah.
then same for D.
Yeah, you got it. Awesome. So now we've got what does it mean to have a negative exponent?
It means viewed.
Yeah, exactly. So let's do that. So what happens here? Beautiful. And I think you pretty much answered it. Let's check it out and
Okay.
see. Yeah.
Okay, so I was just overthinking it.
Yeah, I think probably so because you have the knowledge.
Okay, so do I still put it in the thing?
So
as
they
like-
just want the exponent, I think.
Okay.
So whatever, so I think that 1/2, let's just try that. Oh, just put 1/2, I think, because it's just looking just for that number. There you go. Yeah.
Okay.
Huzzah.
Thank you.
Well done. Yeah,
Thank you.
nice. Yeah, just gotta build the confidence
Yeah.
up, right? How you doing? Everything rocking for you? Oh, working on that one. Awesome. Let me know if you need anything. Everything going okay, Jack?
Yeah, I finished.
Y'all done? Yeah, go, do as you see fit. We're getting done a little early today,
Yeah.
but stay here, go get coffee, more coffee. If you like to read ahead, section, what I'll definitely be covering completely is section 1.5 on Wednesday, and then maybe moving into 1.6, since you're all just cranking this stuff through. And like I said, I'm hoping to have an exam in about 2 weeks, and I think we're gonna do that. I think we'll hit that just fine.
Will the exams be pretty similar to the practice problem?
They will be exactly
Okay.
like the homework.
Okay.
Modeled completely on that, yeah. Got anything you want to talk about? You feeling okay? Right on. Okay, that's good. I love hearing that. See you on Wednesday.
Thank you.
Thank you.
Thank you.
Thank you. Bye-bye. See you in 48 hours or something. Bye. Yay. Good question. So, yeah, it's not. So just that piece you can simplify with the
Okay.
thought process you were doing there, and then +2. So, yeah, and then the two will actually combined after you get that simplified in a nice way.
Okay.
Do you want me to stay here and kind of, or are you good?
I think I'm.
Okay, yeah, I don't want to make you nervous either.